Okay, section 10.6, segment relationships in circles. Okay. So first we have to talk a little bit of vocabulary like we do for every section. Hey, and we're going to talk about the segments of a chord. Okay. A chord, if you have two chords inside of a circle, so when you have two chords that intersect inside a circle. So if I have two chords, so here let's go ahead and let's do a chord here. Let's call it chord A, B, and let's do another chord here. We'll call this guy C, D. And if they intersect here, let's say they intersect at point E, okay, these two chords are divided now up into segments. They're divided into two segments. If you see here, chord AB, so chord AB is divided into two segments. And this is what we call the segments of that chord. Into two segments. We have segment AE and segment EB. AE and then EB. And the same thing happens to chord CD. It's divided into two segments. We have segment CE and segment ED. So those are what we call segments of the chord. Okay, they're segments. A chord itself is a segment, but then it's divided up into other segments. Okay, so one really neat thing happens with these segments of the chords, okay, what's interesting about these segments is if two chords intersect in the interior, then the product of the lengths of their segments, meaning if I look at this length C to D, and if I take its two pieces, so if I go E to D and then E to C and I multiply them, it's the same. So if I take EC times ED right there and multiply them, it's the same as when I multiply these two segments of this chord. Again, this only works in circles, hence it being segments of a chord. Okay, this only works in circles. Don't get this confused with if it's outside of a circle. This does not work. Okay, but that's just how circles work and how chords work inside a circle. Is the product of those pieces. So A to E times EB and D to E times EC. If I multiply those two pieces, multiply these two pieces, they're equal. So I can use that to help me find missing pieces of these chords. So here in example 1, if I want to find the length of AB, that's this whole chord, and the length of PQ, this whole chord, hey, all I need to know is when I multiply the two pieces of the chord. So I'm just going to write that down. If I take B to N and multiply it times NA, NA, the other piece of that chord, then that will equal Q to N times N to P. Okay, so I just need to multiply these pieces and set them equal to each other, and I can then solve for X. Once I know X, I can solve for those lengths. So let's go ahead. B to N is X times N to A is X plus 6. So let's put that in parentheses, times X plus 6. Q to N is X plus 1 times N to P, which is X plus 4. Okay. So I have some binomials, two-term things in here, so I'm going to have to distribute. So if I distribute this, I'll have X squared plus 6X when I distribute that X in. And then I need to distribute on this side. X times X is X squared plus 4X plus 1X plus 4. So I have X squared plus 6X. On this other side, I can put together like terms. X squared plus 5X. Okay, I can subtract the X squared from both sides. So those add out, so I'll have 6X equals 5X plus 4. And then I can subtract the 5X from both sides. So X equals 4. So now I know X equals 4. So that means this length right here, this is why it's nice to have a picture, this length right here is 4. This length would be 4 plus 6, so that would be 10. This one would be 4 plus 1, so 5. 4 plus 4, which is 8. And now if you double check, 4 times the 10 is 40. 5 times the 8 is 40. So the distance from A, so we need to find AB. The distance from A to B would be 10 plus 4, which is 14. And the distance from P to Q P to Q would be 8 plus 5, which is 13. If you notice, the segments are not congruent. These chords are not congruent, but the product of the segments of those chords are equal. Okay. All right, so now we have another bit of vocabulary. We talk about a tangent segment. When we talk about a tangent segment, we're talking about a segment that's tangent to the circle at its endpoint. Okay. So if I was to draw a tangent segment into here, let's see, I want a tangent right there. Okay, let's call that a point A. So then I would just be tangent, I would just have a segment. Let's say it goes here from A to B. So this segment BA is what we call a tangent segment, because there it's tangent at its endpoint. Okay. A secant segment. A secant segment is a segment that contains a chord and has one point outside of a circle. So it contains a chord. So it has a chord in it. Contains a chord, but it has one endpoint outside of the circle. Oop, scratch that. Okay. So like a secant segment would be one maybe like this. So let's call this M, N, P. So my secant segment would be segment PM. Because you see there it does have a chord. Oh, sorry, if you couldn't see that. It does have a chord in here. Chord MN is a chord inside this circle. So it's a chord, but then it has an endpoint here outside. Okay, so the entire secant segment is PM, okay? But the external secant segments always have an external part. The external segment is the part of a secant segment, that's outside of a circle, outside of the circle. Okay, so it would be our external segment here would be this guy here from P to N. There is our external. So our external segment is P to N. So every secant segment is made up of an external segment and a chord. Okay, but has to be together in one long segment there. Okay, so there's our external segment. So here BA is a tangent segment because it's a segment that's tangent to the circle at its endpoint. Okay, a secant segment, so PM is our secant segment, and the external part of that secant segment is PN. Okay. All right, so when I have secant segments, okay, that's a lot of S words. So if I have two secant segments, here EB and here ED, and if they share the same endpoint outside the circle. So here they share the same endpoint, point E out here. Then the product of the lengths of one secant segment. So if I take the product of the whole length, E to B, times the external part, times EA. So if I take EB, the whole thing, times EA, the external part, so the whole thing times the outside part, will equal the whole thing, ED, times the outside part of the other. So the whole thing times the outside part equals the whole thing times the outside part. So the whole segment times the external segment equals the whole segment times the external segment. So be careful. Remember, it's the length of the entire secant segment. So it's the whole thing. That's a little word of caution right there. Whole thing times the outside part. Very common mistake to forget that whole thing aspect. Okay. Right. So here, if I want to find the value of x, if you notice here, I have two secant segments. RQ is a secant segment, and RT is a secant segment. So the whole thing times the outside part will equal the whole thing times the outside part. So the whole thing here, this whole thing, well, I know the external part is 3, the chord is 9, so 3 and 9 is 12. Here the external part is 4. The whole thing would be 4 plus the x, again, because I got this 12 taking the 3 plus the 9. So here would be 4 plus x. So I would need to take the whole thing, RQ, times the outside part, which is RP. And that would equal the whole thing, RT, times the outside part, which is RS. So RQ, whole thing, 12, times the outside part, 3, equals RT, whole thing, times the outside part, which is 4. Okay, so now let's see, 12 times 3, that's 36. I need to take 4 plus x times the 4, so I have to distribute there, so that would give me 16 plus 4x. I'm going to subtract the 16 from both sides, so 0, 20 equals the 4x. Divide both sides by the 4, x equals 5. So here this x would be 5, and if you notice, this whole thing is 12, so 12 times 3 is 36. This whole thing is 9 times 4 is 36, so it did work. Okay. Our very last theorem, honestly, I forget it all the time because I really treat it just like the segment of secants theorem. Again, it's the whole thing times the outside equals whole thing times the outside. Okay, so again, let's write that in words. We have the whole thing times outside equals the whole thing times the outside. Okay, so that's the same, really, that's the same thing on this, except the whole thing and the outside are the same. So here I have a secant segment and a tangent segment. So here I have a secant and a tangent, and then they share an endpoint. Again, we still have that share an endpoint outside the circle bit. Again, which was the same on our last theorem on the other page. Share the same endpoint outside a circle. So here we share the same endpoint outside a circle, this point E. So then the product of the lengths of the secant, again, the whole thing times the outside piece, outside E to C, equals the whole thing, which is EA, times the outside, which is EA again. So really I'm just taking EA times EA. Okay. They write it as EA squared, which is the same as EA times EA. And that's how they write it in the theorem, equals the square of the length of the tangent segment. But me, myself, I'd like to have one less thing to memorize, so I treat this one just like the previous one. Okay. So basically the whole thing times the outside equals the whole thing times the outside. Okay. All right. So here we want to find W. So our goal here, extra example 1, is to find WX. WX, that guy right there. Okay. So here I have a tangent and a secant. So I'm going to need to take the whole thing, which the whole thing of this is x. The whole thing of this one would be 15 plus 12, 727. Okay. So I need to take the whole thing. So the whole thing here would be xz times the outside, which is xy, equals the whole thing, which is wx, times the outside, which is also wx. So x to z is 27, times the outside, which is 12, equals the whole thing, which is x, times the outside, which is also x. So 27 times 12, I don't know that one, 324 equals x times x is x to the second. So then now I would need to square root both sides. So x is equal to the square root of 324. So let's go ahead and let's see if we can't simplify. We want exact. If we can get exact, okay. So let's see the square, let's see if that's a perfect square first. Oh, it is, it's 18. Okay, so x equals 18. And then it's, now it wants you to find wx. Wx is x, so we'd write w big X equals 18. All right, last example here, example 4. So again here I have a secant. This is a secant. It's a bit of an odd secant because it's actually a diameter, still a chord plus outside piece. Okay, so I need to take the whole thing times the outside. And then on this one I need to take the whole thing times the outside. So this whole thing, I have an r plus another r plus 1. So I have an r plus another r plus 1 is the whole thing. and the outside is just 1. Okay, and then here, so I need to take the whole thing, which is WU, times just the outside, which is VU, equals here the whole thing, which is UT, times the outside, which is also UT. So WU would be R plus 1. R plus R is 2R plus 1 times, so I need to take that thing times the outside, VU times 1, equals UT 3 times UT, which is 3. Okay, so 2R plus 1 times 1, that's nice. 2R plus 1 equals 3 times 3, which is 9. Subtract 1 from both sides. 2R is 8. Divide both sides by 2. R is 4. Find the radius of the circle. Hey, we just did. The radius is 4. Okay, so now you have enough to go ahead and do your practice.